Hi, welcome to this Corbettmaths video. In this video, we're going to go through the video solutions to the trigonometry practice questions. If you need any extra help on trigonometry, if you go to corbettmaths.com/contents and you go to videos 329, 330 and 331, there's video tutorials there on trigonometry. Alternatively, you could scan this QR code. But in this video, we're going to go through the video solutions to the trigonometry practice questions, and I'm going to be using the formula triangles in this video. If you prefer rearranging the formula or another approach, go to the website. There's other video solutions there for you. But in this video, I'm using the formula triangles if that's the way your teacher showed you how to do it. So let's get started. Question number one. Question number one says shown below is a right angled triangle. As you can see, it's a right angled triangle. And we've been asked to use trigonometry to work out the size of this angle x. So let's jot down our formula triangle. So we've got two old angels skipped over heaven carrying a harp. So there are trig ratios. Tan is opposite divided by adjacent, sine is opposite divided by hypotenuse, and cos is equal to adjacent divided by hypotenuse. So we've got our trig ratios. Now let's label the sides in our question. So we've got this right angle, so that means the side opposite the right angle is the hypotenuse. And you'll know that from Pythagoras, the hypotenuse is the longest side of the right angle triangle. Now we label that h for the hypotenuse, the longest side of the right angle triangle. Now we've got this angle, the side opposite the angle, so the side opposite that angle is equal to the opposite, so this side is the opposite. And the side that's left is the adjacent, so that would be the side that's adjacent to the angle we're trying to find here. So that's the adjacent, it's the side that's left. So we've labelled our sides, the hypotenuse, opposite the right angle, the opposite the angle we've either been given or trying to find in the question, and the adjacent, the one that's left. And now we know if we have a look at these in each question, then we'll be using two of them, and that's either we're going to be using two of them or we're going to be using one of them and trying to find the other one. But in this question, you can see we're definitely using the hypotenuse and we're using the adjacent, but we're not using the opposite, because the opposite we don't have any length for it and we don't need to use it. So let's cross off the opposite, and let's go up to our trig ratios and cross off the two triangles that involve the opposite. So let's cross off this one and cross off this one. So that means in this question we're going to be using the cos. We're going to be using cos is equal to adjacent divided by hypotenuse. Now in this question we're trying to find the sides of this angle. So that means if we go to our triangle and cover up C, because if you're trying to find the angle, you cover up either the T, the S, or the C, the tan, the sine, or the cos. So because we're trying to find the sides of the angle, we cover up the C, the cos. And that leaves us with adjacent divided by hypotenuse. So let's write that down. The cos of the angle, so the cos of x is equal to the adjacent divided by the hypotenuse, So that means that if we want to find the size of this angle, we're going to do the adjacent divided by hypotenuse, and that'll give us the cos of the angle. And that's our first step to finding the size of the angle. So let's do that. The cos of x is equal to the adjacent, which is 3, divided by the hypotenuse, which is 8. So that means the cos of this angle is equal to 3/8. Now this angle is obviously not equal to 3/8. The cos of the angle is equal to 3/8. So we want to get rid of this cos. And to get rid of the cos, we do the inverse operation. And that will be the inverse cos, or the arc cos, or on the calculator you'll press shift cos. So we want to get rid of this cos, so we're going to write x is equal to, and on our calculator we'll press shift and cos, and it'll come up as cos with a little -1 like so. That's the inverse of cos. And then it'll open up brackets and we'll type in our 3/8 and then close brackets. And if on our calculator we press shift cos and type in 3/8 and close brackets and press equals, it'll give us the size of this angle. And whenever we do that, we get an answer off. So I'm going to just do it now, shift cos and then 3/8 and press equals, and I get that's equal to x is equal to 67.97567 and so on degrees. Now let's round this. I'm going to round this to two decimal places. So it's going to be 67.9, and then we've got 7.5, so let's round up to 9.8. So that means the size of this angle, x, would be 67.98 degrees. And that's it. So we've just used trigonometry to find the size of that angle. Okay, let's have a look at our next question, question number 2. So question number 2, we've got another right angle triangle. You can see it's got a right angle, and we want to find the size of this angle x. So let's jot down our triangles. Two old angels skipped over heaven carrying a harp. So there are trig ratios. Tan is opposite divided by adjacent, sine is opposite divided by hypotenuse, and cos is equal to adjacent divided by hypotenuse. So there are trig ratios, and we're going to be using one of them in this question. So let's label our sides and figure out which one of these we're going to use. So opposite the right angle is the hypotenuse. Opposite the angle we're trying to find in this question will be the opposite. So opposite the angle will be the opposite. And the side that's left, this 20, is the adjacent. Now, if we have a look at this question, we've been given the opposite and we've been given the adjacent, and we're not using the hypotenuse. So let's cross off the hypotenuse and cross off any triangle that involves the hypotenuse. So cross off that one and cross off that one. So in this question, we're going to be using tan. Now, if we go back to our triangle, we're trying to find the sides of this angle. We're trying to find x. So let's cover up t, the tan, because if you're trying to find the angle, you cover up the tan, and that gives us opposite divided by adjacent. So let's write that down. The tan of this angle x is equal to the opposite divided by the adjacent. So we're going to be using that to figure out the sides of this angle. So let's substitute in our values. So the tan of x is equal to the opposite, which is 9, divided by the adjacent, which is 20. So that means the tan of this angle is 9/20. That angle is not equal to 9/20. Obviously, the tan of that angle is. So we now need to do the inverse tan. So that means that x will be equal to, and you'll press shift tan on your calculator and get that tan -1 like so, the inverse tan, and then open up brackets and type 9/20 and press equals, and we'll find the size of this angle. And when we do that, we get x is equal to 24.22774 and so on degrees. And let's round that to 2 decimal places, so that'll be 24.23. So that means that this angle is 24.23 degrees, and that's it. Let's have a look at our next question. So question number three, we've been given triangle ABC, and we're told it's a right angle triangle. And as you can see, it's a right angle triangle. And we've been asked to work out the size of the angle marked X. So we're going to use trigonometry to do that. So let's jot down our triangles. 2 old angels skipped over heaven carrying a harp. So we've now got our trig ratios. Now let's label the sides. So opposite the right angle is the hypotenuse. Opposite the angle we're trying to find in the question would be the opposite, and the other side is the adjacent. So we've labelled our sides, and let's see which one we're not using. So we're going to be using the opposite, we're going to be using the hypotenuse, and we're not using the adjacent. So let's cross off any triangle that involves A. So in this question, we're going to be using sine. And we're trying to find the angle, so we're going to cover up the S, and we're going to do sine is equal to the opposite divided by hypotenuse. So let's write that down. Sine x, you always after the sine, tan, or cos write down what the angle's labelled. So sine x is equal to the opposite divided by the hypotenuse. So just covering that up and doing opposite divided by hypotenuse. So now let's substitute in our values. The sine of x is equal to the opposite, which is 12, divided by the hypotenuse, which is 13. So that means the sine of this angle is equal to 12/13. That angle is obviously not equal to 12/13. Now we want to get rid of the sine, so we're going to do the inverse sine. So x is equal to the inverse sine, so shift sine on your calculator, open brackets and type in 12/13 and close brackets and press equals. And when we do that, we get that's equal to, x is equal to 67.3801 and so on degrees. And if we round it to 2 decimal places, that'll be 67.38 degrees. And that's it. So the size of this angle is 67.38 degrees. Okay, let's have a look at our next question, question number 4. Okay, let's have a look at question number 4. So question number 4, we've been told below is a right angle triangle, and as you can see, it's a right angle triangle. I've been asked to use trigonometry to work out the size of this length here. So we've been asked to use trigonometry to work out the length of this side. So what I'm going to do is I'm just going to jot down our triangles. 2 old angels skipped over heaven carrying a harp. So we've got our trig ratios, and let's label our sides. Opposite the right angle is the hypotenuse. Opposite the angle we've been given is the opposite, and the other side is the adjacent. Now let's have a look and see which side we're not using in this question. Now we're trying to find the opposite, so we're using that. We've been given the hypotenuse, so we're using that. But in this question, we're not using the adjacent, so let's cross that off. So we're not using the adjacent, so we can cross off that triangle, and we can cross off that triangle. So the trig ratio we're going to be using is the sine one. So we're going to be using sine. Now we're trying to find the opposite, so we go back up to our triangle and we cover up O because that's the opposite. And we find that the opposite is equal to the sine, so the sine of the angle multiplied by the hypotenuse. So the opposite is equal to the sine of the angle multiplied by the hypotenuse. So let's write that down. The opposite is equal to the sine of the angle. Now I'm going to write down sine vita here. So I'm using this vita to represent the angle. It's a symbol that I use a lot to represent angles. And if you go to Corbettmaths and watch the video tutorial on trigonometry, I talk about that symbol vita. So I've got the opposite is equal to sine vita multiplied by the hypotenuse. So if I go back up to this triangle and I cover up the O, I've got the opposite is equal to the sine of the angle multiplied by the hypotenuse. So that's what I've written down. The opposite is equal to the sine of the angle multiplied by the hypotenuse. So now let's replace these with what we've been given. So the opposite, so that's x, is equal to the sine of the angle, so that's the sine of 36, so the sine of 36. Now I put my angle in brackets here just because whenever I'm typing it into my calculator, it helps me avoid any issues, multiplied by the hypotenuse, and the hypotenuse is 7. So if we do on our calculator the sine of 36, close brackets, multiplied by 7, that will give us our answer. So the sine of 36, so the sine of 36, and I close brackets because otherwise the calculator thinks I'm doing the sine of 36 times 7, and I'll do 36 times 7 and then do the sine of that, and you'll get the wrong answer. But if you do the sine of 36, close brackets, multiplied by 7, you get that x, the opposite, is equal to 4.114496 and so on centimeters. And let's round that to 2 decimal places. That'll be 4.11. So that means that x, the opposite here, is equal to 4.11 centimeters to 2 decimal places. Okay, let's have a look at our next question, question number 5. So question number 5, we've got our right angle triangle and we've been asked to find the length of x. So let's jot down our triangles. 2 old angels skipped over heaven carrying a harp. So we've got our trig ratios and let's label our sides. Here's our right angle, so that means our x is the hypotenuse. Opposite the 40, opposite the angle we've been given, would be the opposite, and the other side would be the adjacent. Now in this question, we're obviously using the adjacent and we're finding the hypotenuse, so we're not using the opposite. So let's cross off the opposite and cross off the opposite. So in this question, we're going to be using cos. Now we're trying to find, if we look at our question, we're trying to find the hypotenuse. So let's go to our triangle and cover up the h. And we get the hypotenuse is equal to the adjacent divided by cos. So let's write that down. The hypotenuse is equal to the adjacent divided by the cos of the angle, divided by the cos of the angle. And because I was saying the cos of the angle, I like to put beta after it. So we've got the hypotenuse is equal to the adjacent divided by the cos of the angle. So now let's substitute in our values. The hypotenuse, that's x, is equal to the adjacent, which is 25, divided by the cos of the angle. So that's the cos of 40. And now we just type this in on our calculator. We do 25 divided by the cos of 40, and that's equal to x is equal to 32.63518 and so on centimeters. And let's round this to 2 decimal places. That'll be 32.64. So that means the length of x is equal to 32.64 centimeters to 2 decimal places. And that's it. Okay, let's have a look at our next question, question number 6. So we've got triangle RST, and we've been asked to find the length of RT. Let's call that x. So let's jot down our triangles. 2 old angels skipped over heaven carrying a harp. And let's label the sides in our question. So we've got our right angle here, so that means that's the hypotenuse. Opposite the angle would be the opposite, and the side that's left, this x, is the adjacent. Now if we have a look at our question, we're going to be using 2 of those. So we're going to be using the opposite, which is 14 centimeters. We're trying to find the adjacent, but we're not using or having to find the hypotenuse. So we can cross off the h and cross off the 2 triangles involving h. So in this question, we're going to be using tan. So we're trying to find the adjacent. So we go to our triangle and cover up the A here. We get the adjacent is equal to the opposite divided by the tan of the angle. Because we're trying to find the adjacent, we cover up A and we get O divided by T, the opposite divided by the tan of the angle. So let's write that down. The adjacent is equal to the opposite divided by the tan of the angle, so tan veta. And again, I like putting veta there, just remember it's the tan of the angle. Now we want to substitute in our values, so the adjacent, which is x, is equal to the opposite, which is 14, divided by the tan of the angle, so the tan of 53. And if we just do 14 divided by the tan of 53, so 14 divided by the tan of 53, we get that x is equal to 10.5497567 and so on centimeters. And let's round this to 2 decimal places. That'll be 10.55 because it's 4 now. We're going to round up, so 10.55 centimeters. And that's the length of RT. And that's it. Okay, let's have a look at our next question, question number 7. So question number 7, we've been given triangle ABC, and it's a right angle triangle, and we're told the angle BAC is 25 degrees, and we've been asked to calculate the length of AB, so that's that length there, AB, and let's call it X. Now let's jot down our triangles. 2 old angels skipped over heaven carrying a harp. So there's our triangles, and let's label our sides. Opposite the right angle is the hypotenuse. Opposite the angle we've been given in the question is the opposite, and the side that's left would be the adjacent. Now in this question you can see here the opposite we've not been given, and we're not trying to find it, so we can cross it off. We can cross off any triangle involving that O. So that means we're going to be using the cos, and we're trying to find the adjacent here. We're trying to find what x is, the length of AB, which is the adjacent. So we go up to our triangle and we cover up the A, and we get the adjacent would be equal to the cos of the angle multiplied by the hypotenuse. So let's write that down. The adjacent is equal to the cos of the angle, so I'm going to write cos veta multiplied by the hypotenuse. Now let's substitute in our values. So instead of the adjacent, we're going to use x. The cos of the angle, so that's going to be cos of 25. Now remember that we put that in brackets, the cos of 25, close brackets, and then multiply by the hypotenuse, which is 12.5. So 12.5. So if we just type into our calculator, the cos of 25, close brackets, multiplied by 12.5, we'll find the length of AB, which is x. So that's equal to the cos of 25, close brackets, multiplied by 12.5 is equal to 11.3288 and so on centimeters. And if we round that to 2 decimal places, that'll be 11.33. So that means the length of AB is equal to 11.33 centimeters. And that's it. So question number 8 says, triangle DEF is a right angle triangle. So this is a right angle triangle, and we've been asked to calculate the sides of angle DEF. So we want to find the sides of this angle up here. So this is the angle we're trying to find. So I'm just going to call it beta. And let's write down our trig ratio. So we've got 2 old angels skipped over heaven carrying a harp. So we want to find the sides of angle DEF, so we've just labelled it. And let's label the sides in this question. So opposite the right angle is the hypotenuse. Opposite the angle we're trying to find is the opposite, and the side that's left is called the adjacent. Now one of these sides we're not using the adjacent. We're obviously going to be using the hypotenuse and the opposite, so we can cross off all the triangles involving the adjacent. So cross off that one and that one. So we're going to be using sine in this question. Now in this question we're trying to find the sides of the angle, so we're going to cover up the S for sine. So remember, if you're trying to find an angle, you would cover up the T, the S, or the C. So we're covering up the S, which is the sine, and that means the sine of the angle is going to be equal to the opposite divided by hypotenuse. So let's write that down. The sine of the angle, sine theta, is equal to the opposite divided by the hypotenuse. So let's substitute in our values. The sine of theta, well, the sine of theta is equal to the opposite, which is 8, divided by the hypotenuse, which is 10.5. So we know that the sine of the angle is equal to 8 divided by 10.5. Now obviously this angle is not equal to 8 divided by 10.5. That's the sine of the angle. So we want to get rid of that sine, so we want to do the inverse sine, and that will give us that theta is equal to, and if we do the inverse sine, that's the sine minus 1, so shift sign on our calculator, and then 8 divided by 10.5 and close brackets, that will give us the sides of this angle. So now you could work out what this is, 8 divided by 10.5, and it'll give you a decimal number, and you could do the shift sign of that decimal number, and that will give you your answer as well. I tend to just type it in as a fraction, so shift sign, and then my fraction button, and then 8 over 10.5 is equal to, and we've got the theta is equal to 49.632 and so on degrees. And to 2 decimal places, that means the angle DEF will be equal to 49.63 degrees. And that's it. Okay, let's have a look at our next question, question number 9. So question number 9, we've got a right angle triangle, and it's just been turned slightly, so it's still a right angle triangle. And we've been asked to work out the length of side x. So we want to find the length of this side, and we've been asked to include suitable units. Now if you notice here, we're using millimeters, so that's important that we make sure that we use millimeters in our answer. So we have got our angle, and we've got a right angle, and let's jot down our triangle. So 2 old angels skipped over heaven carrying a harp. And let's label the sides. Opposite the right angle is the hypotenuse. Opposite the angle we've been given in the question is the opposite, and the side that's left, this side, would be the adjacent. Now if you notice in this question, we're trying to find the hypotenuse, and we've been given the opposite, and we're not using the adjacent, so we can cross off the A, and we can cross off any triangles involving the A, the adjacent, and we're left with sine. So in this question we're going to be using sine, and we want to find the length of this side, which is the hypotenuse. So we'll go up to our triangle and we'll cover up our H, and the H, the hypotenuse, is equal to the opposite divided by the sine of the angle. So the hypotenuse is equal to the opposite divided by the sine of the angle. So let's substitute in our values. The hypotenuse, that's x, is equal to the opposite, which is 55 millimeters, divided by the sine of the angle, so the sine of 68. And if we do 55 divided by the sine of 68 in our calculator, that'll give us the length of the side. So 55 divided by the sine of 68 is equal to, x is equal to 59.319 and so on millimeters. And let's round that to 2 decimal places. That'll be 59.32 millimeters. So that means the length of that side is 59.32 millimeters. And that's it. Okay, let's have a look at question number 10 now. The first thing I noticed about question 10, it's a non-calculator question, so I'm just putting down my calculator reluctantly. And we've got our right angle triangle, and we've been shown this right angle triangle, and we've got this right angle, and we've been asked to find the size of x. We want to find the length of this side. So let's jot down our triangles. 2 old angels skipped over heaven carrying a harp. And we've got that, if we label our sides, we've got our right angle, so this is our hypotenuse. The angle we've been given in the question is the 30 degrees. That means the side opposite it is called the opposite, and the side that's left is the adjacent. Now, as you can see, we're trying to find the opposite. We're using the hypotenuse and we're not using the adjacent, so we can cross off the A, and that means we can cross off that triangle and cross off that triangle, and we've been left with sine. And that's quite nice, because if you have a look, we've been given some information in the question that the sine of 30 is equal to 0.5. So, that's quite nice that we've got that we are using sine. If we were found that we were using the cos triangle, I'd be a bit confused in this question. Okay, so we're trying to find the opposite here. So if you have a look, we're trying to find the opposite. X is the opposite. So if we go back up to our triangle and cover up the O, we get the opposite is equal to the sine of the angle multiplied by the hypotenuse. So let's write that down. The opposite is equal to the sine of the angle, so sine theta multiplied by the hypotenuse. So that's just covering up the O and doing the sine of the angle multiplied by the hypotenuse, and I've just written that down. So let's substitute what we've got. We've got the opposite, which is equal to x, is equal to the sine of the angle, so that's the sine of 30 multiplied by, and I'm just going to put that in brackets, the sine of 30 multiplied by the hypotenuse, which is 16. Now in this question, it's a non-calculator question, so normally at this point we would just type this into our calculator, but we just press the sine of 30, close brackets, multiply by 16 and see what we get. But here we're told, it's a non-calculator question, and we're told the sine of 30 is 0.5, so we get that x is equal to, and we've got the sine of 30 is 0.5, so we can just replace the sine of 30 with 0.5 times by 16. So to find x, we're just going to do 0.5, which is a half, times 16. And a half of 16 is 8. Or if you had 16 halves, that's equal to 8. So that means that x is equal to 8. So that means the length of the side is 8 centimeters. And that's it. Okay, so let's have a look at our next question, question number 11. Okay, let's have a look at question number 11. So question number 11 is about a ladder, and you can't have some practice questions on trigonometry without involving some ladders and walls. So we've got a ladder placed against a vertical wall, and to be safe, it must be inclined at between 70 and 80 degrees to the ground. So in other words, because it's inclined to the ground, it's saying that this angle here must be between 70 and 80 degrees. In other words, if this angle is too big, if the ladder's too steep, what would happen is if you climbed on it, it might tip backwards, or if this angle's too small and if the ladder's further out, and if you get on it, the ladder might fall. So the ladder must be at a safe angle for somebody to climb up it, and it must be between 70 and 80 degrees to the ground. So it must be inclined to the ground between 70 and 80 degrees. And we've been asked, is the ladder safe? So in other words, we want to find the sides of this angle theta. And if we can find the sides of this angle, and if it's between 70 and 80 degrees, then the ladder's safe. Hopefully. So just to begin with, let's jot down our triangles. 2 old angels skipped over heaven carrying a harp. And let's label our sides. We've got our right angle here, so that means that we've got our hypotenuse opposite the right angle. The side opposite the angle is equal to the opposite, and the side that's left is equal to the adjacent. Now in this question, we don't know the length of the ladder, so we can cross off the h because we don't know the length of this side. And we've been given the opposite and the adjacent, so that's what we're going to be using in this question. So let's cross off any triangles involving h. That's that one and that one. So it means we're going to be using tan, and we want to find the sides of the angle. So that means we're going to cover up our t, the tan of the angle. So when we cover up our t, we get that the tan of the angle is equal to the opposite divided by the adjacent. So let's write that down. The tan of the angle is equal to the opposite, so the opposite divided by the adjacent. And let's replace the opposite with 5.8 and the adjacent with 1.5. So the tan of our angle, which is theta, is equal to the opposite, which is 5.8, divided by the adjacent, which is 1.5. So that means the tan of this angle is equal to 5.8 divided by 1.5, and you could work that out if you wanted to, and that'll be probably just under 4, be 3 point something, I think. But this angle is obviously not 3 point something degrees, so what we want to do is we want to get rid of the tan. So we're going to do the inverse tan. So it would be theta is equal to, and the inverse tan would be, well, that's the tan with a little -1, shift tan on our calculator. And again, you could have worked this out and typed it as a decimal number if you wanted to. I'm just going to type it in as a fraction on my calculator, so I'm going to press shift tan, so shift tan, the fraction button, and I'm going to put in 5.8 over 1.5, and when I do that on my calculator I get an answer of, so actually 5.8 over 1.5, close brackets, and when I press equals on my calculator I get that's equal to 75.4998 and so on degrees. So that means the sides of this angle to one decimal place would be 75.5 degrees. Now if we go back up to the question, we were told if the angle's between 70 and 80 degrees, it's safe. So to be safe, it needs to be between 70 and 80 degrees. So this angle is 75.5 degrees, so that is between 70 and 80. So is the ladder safe? Yes, and that's it. Okay, let's have a look at part B. Part B says calculate the length of the ladder. Now, in terms of calculating the length of this ladder, I could use trigonometry because we've now found an angle, and we could use this angle on one of the other two sides to calculate the length of the side. I'm not going to do that because for a couple of reasons. One is I may have made a mistake in part A. And if I've made a mistake in part A, my angle won't be right. Another reason is the angle, if we have a look at it, was 75.4998 and so on. It's quite long and it would just carry on. And if I was to round it, it might affect the accuracy for how long that ladder is. Now, if we have a look here, we've got a right angle triangle and we've got two sides. So I actually would just use Pythagoras in this question. I've got a right angle triangle with two sides, and I would use, and the two sides are the ones that I've been given in the question. And they're not big long decimal numbers, so they're small, they're numbers that are quite easy to use, and there's no risk of them being incorrect. They're right, as long as I know Pythagoras. So what I'm going to do is I'm going to sketch this and I'm going to use Pythagoras. Now I could have used trigonometry if I wanted to, and they would give me the right answer. And as long as I use a sort of an accurate version of that angle, it would be correct. So let's do that. And also just to mention that later on in the video, you'll see that sometimes we have to use the angle anyway. So let's do that. Let's do our sketch. So if we have a look here, we've got this right angle triangle and we've got 1.5 meters and 5.8 meters and the ladder. So let's go down and have a look at our sketch here. So we've got 1.5 meters and 5.8 meters. We've got our right angle triangle, and let's use Pythagoras to find the length of this angle. So let's label the sides. So remember in Pythagoras, we label the sides A, B, and C, where A and B are the two shorter sides and C is the hypotenuse. And in terms of Pythagoras, it's A squared plus B squared is equal to C squared. So if we square the two shorter sides and add them together, that's equal to the length of the longest side squared, or the hypotenuse squared. So let's substitute in our values. So instead of A squared, we're going to write 1.5 squared. And instead of B squared, we're going to write 5.8 squared. And that's equal to C squared. So now let's do this in our calculator. And so 1.5 squared plus 5.8 squared is equal to 35.89, and that's equal to C squared. Now the ladder is obviously not equal to 35.89, that's C squared. So we now need to square root. So let's actually just turn that around. C squared is equal to 35.89. And if we square root this, we're going to get that C is equal to the square root of 35.89, and that's equal to the square root of that is equal to 5.9908 and so on meters. And let's just round that to two decimal places. That's equal to 5.99 meters. So the length of the ladder is 5.99 meters. And as mentioned, you could have used trigonometry for that question and used the angle we found in part A. And sometimes you have to use that. And we'll see some questions later on where we will be doing that. But just in this question, I thought if I could avoid it and use Pythagoras, that I would. Okay, let's have a look at our next question, question number 12. So question number 12 says a ramp is built to help people enter a building. And the start of the ramp is 2.1 meters from the base of the building. And the ramp has a height of 20 centimeters. Calculate the size of angle Y. So we want to find the size of this angle. Now the first thing I notice is with this ramp, it's quite a long ramp. It's 2.1 meters, but it's got a height of 20 centimeters. We've got two different sets of units here. And it's very important whenever we're doing trigonometry that we're using, just centimeters or just meters and so on. So what I'm going to do is I'm going to change the 2.1 meters to 210 centimeters, because in each meter there's 100 centimeters. So 2.1 meters would be 210 centimeters. Okay, so we want to find the size of this angle. So let's jot down our triangles. Two old angels skipped over heaven carrying a harp. And let's label our sides. So we've got the right angle here, so that's the hypotenuse. So opposite the right angle is the hypotenuse. Opposite the angle we're trying to find is the opposite, and the other side is called the adjacent. So we've got the hypotenuse, opposite the right angle, the opposite, and the adjacent. Now in this question, you can see we're going to be using the opposite and the adjacent, and we're not using the hypotenuse, so let's cross off the hypotenuse and cross off the hypotenuse. So in this question, we're going to be using tan. Now we're trying to find the size of the angle. That means we cover up the t, and we find that the tan of the angle is equal to the opposite divided by the adjacent. So let's write that down. The tan of the angle, so tan y, is equal to the opposite divided by the adjacent. So we know that the tan of the angle is equal to the opposite divided by the adjacent. Now let's substitute in our values. So the tan of y is equal to the opposite, which is 20, divided by the adjacent, which is 210, because we're using the same units. So that means the tan of the angle is equal to 20 over 210. Now this angle is obviously not equal to 20 divided by 210. That's the tan of the angle. So we want to get rid of the tan, so we want to do the inverse tan. So if we go up here, that's going to be that y is equal to the inverse tan, so that's tan minus 1, or shift tan. And we could do 20 divided by 210 and write it as a decimal number. I'm just going to keep it as a fraction, so I'm going to write 20 over 210, close brackets. And if I type this into my calculator and press equals, we'll find the size of this angle. And we find that y is equal to 5.4403 and so on degrees. And if we round this to two decimal places, it's equal to 5.44 degrees. So the size of this angle is 5.44 degrees. And that makes sense because with a ramp, you probably wouldn't want it to be too steep. And that's it. Okay, let's have a look at our next question. Okay, let's have a look at question number 13. So question number 13 says, shown below is a right angle triangle DEF. So we've got DEF and it's a right angle triangle. And we're told that angle E is 12 degrees larger than angle D. So actually using that information, we can actually work out the sides of these two angles because we know that the angles in a triangle add up to 180 degrees. Now if we know that this one is 12 degrees larger than that one, let's call this one X. Let's call this angle here X. And for this one's 12 degrees larger, this would be X plus 12. We would add 12 onto the sides of this one to get this one. So this is X plus 12. Now let's use that information to find the sides of these two angles. So the angles on a triangle add up to be 180 degrees. This is obviously 90 degrees. So that means we've got X plus 12 plus 90 is equal to 180 degrees. If we add up the three angles, X plus 12 and 90, we'll get 180 degrees. Now let's simplify this left-hand side. We've got X plus X, that's 2X. And then we've got 12 plus 90, that's 102. And that's equal to 180. And then if we subtract 102 from both sides of the equation, what we're going to get is 2X on the left-hand side. And on the right-hand side, we'll be left with 78. And if we divide by 2 and divide by 2, we'll find out that X is equal to 39 degrees. So that means that X, this angle, is 39 degrees. So that's 39 degrees, and this angle is 12 degrees larger, so if we add 12, that'll be 51 degrees there. So this angle D is 39 degrees and angle E is 51 degrees, and as you can see, angle E is 12 degrees larger than angle D, and the two angles add together to be 90 degrees, and 90 plus 90 is 180. Now that's fantastic, because now we know the sides of these angles, 39 degrees and 51 degrees, we can use trigonometry to find out the length of DE. So let's jot down our triangles. Two old angels skipped over heaven carrying a harp, and let's label our triangle. Now in terms of our two angles, we can use either one of them in this question whenever we're labeling the question, because obviously if we use 39 degrees, that would be the opposite, but if we use 51 degrees, that'll be the opposite. I'm going to focus on this 39 degrees, and this is the one that I'm going to use to label our triangle. So first of all, let's start off with the hypotenuse. That's opposite the right angle, that's the hypotenuse. If we're using the 39 degree angle, this is then our opposite, and the other side, this side here, would be our adjacent. Our 50 centimeters is our adjacent. So if we label the sides of the triangle, we've been given the adjacent, we want to find the hypotenuse, so we're not using the opposite. So let's cross off the O, and let's cross off the triangles that use the O. So we're left with cos, so we're going to be using cos in this question, and we're trying to find the hypotenuse. So let's cover up our H, and we've got that the hypotenuse is equal to the adjacent divided by the cos of the angle. So let's write that down. The hypotenuse is equal to the adjacent divided by the cos of the angle, or cos vita. So we've got the hypotenuse is equal to the adjacent divided by the cos of the angle. Now let's substitute in our values. So the hypotenuse, well in this case that's DE, so let's call that DE. And then we've got our adjacent, and our adjacent is 50 centimeters, so that's 50, divided by the cos of the angle, and the angle we're using is 39 degrees, that's the cos of 39. So if we do 50 divided by the cos of 39, we'll find the size of DE, and that's what we've been asked for. So whenever we do that, we get, and that's equal to 64.33797 and so on centimeters. And let's give our answer to two decimal places. That means that DE, the length of the hypotenuse, would be 64.34 centimeters to two decimal places, and that's it. Okay, let's have a look at our next question. Question number 14. So question number 14 says, shown are two right angle triangles. So we've got two right angle triangles and they're joined, and we've been asked to calculate the value of x, the length of this side here. Now if we have a look at this triangle at the bottom, we've only got the sides of this angle here, the 38 degrees, and obviously the right angle. So we would need the length of one of the other sides to be able to use trigonometry to find the length of this side here. So let's look at the triangle at the top. We've got this side is 5 centimeters. We've got the sides of this angle is 50 degrees. So if we use trigonometry, we can work out the length of this side here. And if we can work out the length of this side, then we can use trigonometry again to find the length of that side. So let's focus on this triangle on the top. So let's label the sides. We've got the hypotenuse. That's the hypotenuse there. That's the hypotenuse. This would be the opposite. So let's label the O for opposite. And the 5 centimeters would be the adjacent. Now let's jot down our triangles. Two old angels skipped over heaven carrying a harp. Now in terms of this triangle that we've labelled the opposite, the hypotenuse and the adjacent, we want to find the opposite. We've been given the adjacent, we're not using the hypotenuse, so let's cross off the H and cross off the triangles that use the hypotenuse. So we're going to be using tan, and we want to find the opposite, so let's look at our triangle and cover up the O. The opposite is equal to tan of the angle multiplied by the adjacent. So let's write that down. The opposite is equal to tan of the angle, so tan vita, multiplied by the adjacent. So we now know that the opposite is equal to tan of the angle multiplied by the adjacent. Let's substitute in our values. So the opposite, well that's what we're trying to find, the opposite is equal to the tan of the angle, so that's 50 degrees, so the tan of 50 degrees, and then close brackets, multiplied by the adjacent, which is 5 centimeters. So if we do tan of 50 multiplied by 5, that'll tell us the length of this side here. So let's do that. And that's equal to 5.958767963 and so on. So I've kept that on my calculator display, and I'm not going to round it because if I round it, I'm going to maybe lose some accuracy. So that's the length of this side here, and that's in centimeters. And actually, let's write it on this triangle here. And I'm actually going to change color of ink to red. That's 5.9587 and so on centimeters. So that's now the length of this side. We've got the angle, and we want to find the length of this side x. So now let's look at this triangle and label our sides again. So if we have a look at this right angle, that means the side opposite it is going to be the hypotenuse. But we're going to be using this angle, which is 38 degrees, and the side opposite it is then this one, so that's the opposite. And the other side, so we've got the hypotenuse, we've got the opposite, so that means that this side now is now the adjacent. So for this triangle and that angle, that's now the adjacent. So if we have a look at our sides, we're trying to find the opposite, we've worked out the adjacent, and we're not using the hypotenuse. So let's cross off the hypotenuse, and let's jot down our triangles. 2 old angels skipped over heaven carrying a harp. Now we're not using the hypotenuse, so we cross off the triangles that involve h. So we cross off that one, and we're left with tan. So we're going to be using tan in this question, and we want to find the length of the opposite. So if we cover up the opposite is equal to tan of the angle multiplied by the adjacent. So let's write that down. The opposite is equal to tan of the angle multiplied by the adjacent. Now if we substitute in our values, the opposite, which is x in this question, is equal to tan of the angle, so that's the tan of 38, so tan of 38, I'm going to put that in brackets, multiplied by the adjacent, and that's the 5.9587 and so on. It's still on my calculator display. So I'm now going to work out what this is, so I'm going to press the tan of 38, close brackets, multiplied by answer, so that then means it uses that value for us, and press equals, and we get that x is equal to 4.6554999 and so on centimeters. And now we're finished, we can round that answer, and let's round it to 2 decimal places, so that'll be 4.66. That's 4.66 centimeters, and that's it. So the length of this side is 4.66 centimeters. Okay, let's have a look at our next question, question number 15. So question number 15 says 2 right angle triangles are shown below. So we've got these 2 right angle triangles. We've got this one and we've got this one. We're told that AB, so AB is 10 centimeters, that BC is 3 centimeters, and angle BCD, this angle is equal to 65 degrees. And the question says calculate the size of angle ABD. So we want to find the size of this angle. So if we have a look at this triangle on the top, we only know the length of the hypotenuse. And if we want to find the size of the angle, we're going to want to know one of the other lengths on that triangle. So let's look at the triangle beneath this right angle triangle here. So we've got this angle of 65 degrees. We've got the length of this side. So we can then use trigonometry to work out the length of BD. And if we can work out the length of BD, that then means we can use it in the top triangle to work out the sides of the angle. So let's focus on the bottom triangle to begin with. So let's look at this triangle and let's label our sides. So we've got the right angle here. So that means the side opposite it, CD, will be the hypotenuse. We've got our 65 degree angle. So that means the side opposite it will be the opposite. And then the side that's left, this BC, the 3 centimeters, will be our adjacent. So we've labelled our sides. Now we want to find the opposite. We've been given the adjacent. We're not using the hypotenuse, so we can cross that off. And actually we can jot down our triangles. 2 old angels skipped over heaven carrying a harp. Now in this question we're not using the hypotenuse, so we can cross off that triangle and cross off that triangle. And in this question we're going to be using tan. So we're going to be using tan, and we want to find out what the opposite is. So we cover up the opposite and we do the tan of the angle multiplied by the adjacent. So opposite is equal to tan of beta multiplied by the adjacent. And we can substitute in our values. So we're trying to find the opposite, which is BD. So BD, and that's equal to tan of the angle. So that's the tan of 65. And I'm just putting that in brackets, multiplied by the adjacent, which is 3 centimeters. And I've just moved that up to give us a bit more room. So to work out BD, the length of this side, we're going to do tan of 65 multiplied by 3. So let's do that. And that's equal to 6.433520762 and so on centimeters. So that's the length of BD. Now what we want to do is we want to look at this triangle at the top. We now know, I'm actually going to change colour of ink to blue. So we're now going to use blue ink for this triangle on the top. And we want to find the size of this angle, angle ABD. So what is labelled X on our diagram. So we now know, let's actually put in our 6.433520 and so on. So that's the length of the side. And I've left it on my calculator display because we're going to use it in a moment. So we've got our triangle on the top. Let's label our sides. So we've got the right angle here. So that means this side is the hypotenuse. So the 10 centimeters is the hypotenuse. If this is our angle we're trying to find, our x, the side opposite it is called the opposite. So that's O here. And that means that our length BD is now the adjacent. So that's now the adjacent. And if we just go through that again, AB is going to be the hypotenuse because it's opposite the right angle. Our side AD is going to be the opposite because it's opposite the x we're trying to find, the angle we're trying to find. And the side that's left, the BD, is going to be the adjacent. So let's jot down our triangles. 2 old angels skipped over heaven carrying a harp. So now let's have a look and see what sides we're using. Well, we're using the adjacent and we're using the hypotenuse, so we're not using the opposite. So let's cross off the triangles with O in it. So that's the first two triangles out. So we're going to be using cos. So we want to find the sides of the angle, so we cover up the C. So remember, whenever we're trying to find an angle, you cover up either the cos, the sin, or the tan. So we cover up the C, and that means the cos of the angle will be equal to the adjacent divided by hypotenuse. So let's write that down. The cos of the angle, so cos x, is equal to the adjacent, which is adjacent, divided by the hypotenuse, so divided by the hypotenuse. So we know the cos of the angle, so cos x is equal to the adjacent divided by hypotenuse. So let's substitute in our values. The cos of x is equal to the adjacent, which is equal to 6.43352 and so on. It's still on my calculator display, divided by the hypotenuse, which is 10. So that means the cos of the angle is equal to 6.4335 and so on over 10. Now this angle obviously isn't equal to that. So what we want to do is we want to get rid of the cos. We're going to do the inverse cos. So that means that our angle x is equal to, so the inverse cos of 6.4335 and so on over 10. Now you could work this out, but I tend to just type it into my calculator like that. So I'm going to press shift, cos, and then I'm going to press the fraction button and press answer because that's already on my calculator display. So answer, and then scroll down, press 10, and then close brackets. And whenever I do that, I get that x is equal to, it says this angle is equal to 49.957 and so on degrees. And let's just round that to 2 decimal places. So that'll be 49.96 degrees, and that's it. Okay, let's have a look at our next question, question number 16. So question number 16 is a non-calculator question, so I've just put down my calculator, and the question says the diagram shows a right angle triangle. So we've got this right angle triangle, and we've got 25 degrees, the length of the hypotenuse is 10 centimeters, and we're trying to find the length of this side, x. And then we've got this table, which has angle, 25 degrees and 65 degrees, and then we've got the sine, the cosine, and the tangent. So the sine of 25 degrees would be 0.423 to 3 decimal places. The cos of 25 degrees would be 0.906. And the tan of 25 degrees would be 0.466, and they're all 3 decimal places. And likewise, the sine of 65, the cos of 65, and the tan of 65 are all shown here below on this bottom row. And we've been asked to work out the length of the side x. So let's label our sides. We've got the hypotenuse, which is obviously opposite the right angle. The side at the bottom, that's opposite the 25, so that's the opposite. And the side that is left, the x is equal to the adjacent. So let's jot down our triangles. 2 old angels skipped over heaven carrying a harp. So we've got our trig ratios, and let's have a look and see which ones we're using in this question. So we've been given the hypotenuse, so we're going to use that. We're trying to find the adjacent, so that's what we're trying to find. So the opposite we're not using, and we're not trying to find in this question. So let's cross off the triangles with O in it. So that's that one and that one. So that means we're going to be using cos in this question. Now if we have a look at our triangle, we're trying to find the adjacent. So that means if we cover up the A, the adjacent is equal to the cos of the angle multiplied by the hypotenuse. So let's write that down. The adjacent is equal to the cos of the angle, so cos veta multiplied by the hypotenuse. And let's substitute in our values. The adjacent, which is x, is equal to the cos of the angle, so that's going to be cos 25, so cos 25, I'm going to put it in brackets, multiplied by the hypotenuse, and the hypotenuse is 10. So that means that x is equal to the cos of 25 degrees. Now if we have a look here, we've got the cosine of 25 degrees, so that would be equal to 0.906. So let's replace this cos of 25 with 0.906. That means that x is equal to 0.906 multiplied by 10. And if we do 0.906 multiplied by 10, that's equal to 9.06 centimeters. So that means the length of this side here, this side x, would be equal to 9.06 centimeters. And that's it. Okay, let's have a look at our next question. Okay, let's have a look at question number 17. So question number 17 says ABC, so ABC is a right angle triangle. And we're told the tan of this angle, so the tan of x is equal to 0.6. Work out the length of BC. So we want to find the length of BC. So let's jot down our triangles. 2 old angels skipped over heaven carrying a harp. And let's label our sides. So we've got this angle and we've got the right angle. So if we start off with the right angle, the side opposite it is called the hypotenuse. So that's the hypotenuse. Then we've got the angle, this angle x, so the side opposite it will be the opposite, and then the side left, this 8 centimeters, will be the adjacent. So we've labelled our sides, and let's have a look and see which ones we're going to be using. So we're going to be using the adjacent, that's 8 centimeters. We want to work out the length of BC, so we want to work out the length of this side, so we're trying to find O, and that means we're not using the hypotenuse, and we're trying to find the hypotenuse, so let's cross off the hypotenuse. So we're not using that triangle, and we're not using that triangle. So in this question, we're going to be using tan. Now we want to work out the length of the opposite. We're trying to find BC, so we're trying to find the opposite. So if we cover up O, that's equal to the tan of the angle multiplied by the adjacent. So let's write that down. The opposite is equal to the tan of the angle multiplied by the adjacent. So that means the opposite is equal to the tan of the angle multiplied by the adjacent, just multiplying those together. Now, so let's substitute in our values. So the opposite, so let's call that BC because that's what we're trying to find. BC is equal to the tan of the angle. Now in this question, we're told the tan of the angle is equal to 0.6. So we're not going to be doing the tan of the angle because we don't actually know what the angle is. We're not shown what the angle is, but we're told the tan of the angle. They've calculated it for us already, and they've told us that it's 0.6. So instead of writing tan x, the tan of this angle, we can just write 0.6 because we're told that. And then we're going to multiply that by the adjacent, and the adjacent is equal to 8. So multiply by 8. So that means to work out the length of this side BC, we just need to do 0.6 multiplied by 8. So let's do that. So BC is equal to 0.6 multiplied by 8. Now 6 times 8 is equal to 48. So 0.6 times 8 will be equal to 4.8. So that means that BC is equal to 4.8 centimeters. And that's it. So the length of this side BC is 4.8 centimeters. Now in this question, this was just a bit different than the ones we've done so far because normally we're told what the angle is and we have to work out what the tan or the sine or the cos of the angle is. But in this question, it just told us the tan of the angle is 0.6 and we were able to just write that down. And that's it. Okay, let's have a look at our next question, question number 18. Okay, let's have a look at question number 18. So question number 18 says, shown below right angle triangles ABD, so ABD, and BCD, so BCD. So we've got these two right angle triangles that are joined together, and we're told that AB, so AB is equal to 15 centimeters. So that side, AB is 15 centimeters. Angle ABD is 70 degrees. And then we're told the ratio of angle ABD, so that angle, to angle DBC, this angle, so the ratio of that angle to that angle is 5:2. And then the question says, work out the length of CD. So we want to find the length of CD. So I'm just going to label that with an X. That's what we're trying to find. Now, in this question, it would be really useful if we could actually use this information to work out the size of this angle. So let's do that. Let's work out the size of this angle. We're told the ratio of this angle to this angle is 5:2. So that means if we divide the 70 by its number in the ratio 5, so if we do 70 divided by 5, that's equal to 14. And then if we multiply by the number in the ratio 2, that'll tell us the size of this angle. So if we do 14 multiplied by 2, that's equal to 28. So that means that this angle is equal to 28 degrees. And we can check that if we just write that down as a ratio, 70 to 28, so 70 to 28. We could cancel it down by dividing them both by 7 to begin with to get 10 to 4, and we can then half it to get 5 to 2. So it means that angle must be 28 degrees. Fantastic. Now we want to work out the length of CD, the length of this side here. Now if you actually have a look at this triangle on the right hand side, apart from the angle, we don't actually have any other measurements on it. So we're going to have to look at this triangle on the left hand side, this triangle ABD. And let's use trigonometry to work out the length of BD. If we can work out the length of BD, then we can use it on this triangle on the right hand side. So let's start off with this triangle here, so triangle ABD. So let's label our sides. We've got the 70-degree angle, we've got the right angle. So if this is the right angle, this is then the hypotenuse. Then we've got a 70-degree angle, so that means the side opposite it. This one would be the opposite. And then that means that BD is the adjacent. So we've labelled the sides, and let's jot down our triangles. Two old angels skipped over heaven, carrying a harp. Now we want to work out the size of the adjacent, so we're trying to find that, and we've been given the hypotenuse. So in this question, we're not using or trying to find the opposite. So let's cross off the triangles with the O, so that's that one and that one, and we're left with this triangle. So we're going to be using cos in this question, and we're trying to find the adjacent. So if we go to that triangle and cover up the A, we've got the cos of the angle multiplied by the hypotenuse. So it means the adjacent is equal to the cos of the angle multiplied by the hypotenuse. So let's substitute our values. The adjacent, well, that's BD, so BD is equal to the cos of the angle, so that's the cos of 70 degrees, so the cos of 70 degrees, close brackets, multiplied by the hypotenuse, which is 15. So if we do the cos of 70 multiplied by 15, it'll give us the length of this side. So let's do that. So BD equals, 5.13030215 and so on. So that's the length of that side, 5.13 and so on centimeters. And I'm not going to run that answer, and I'm going to keep it on my calculator display because we're going to probably use it for this right hand triangle. Well, we are going to use that number on our right hand triangle. So let's now change color of ink, and I'm going to change the green because we've used red to begin with to find the size of that angle. I've used blue on this right hand triangle, so now I'm going to use green now to work out the length of the side B. So we know that the length of this side BD is equal to 5.130 and so on centimeters. We've got this angle here is 28 degrees, and we're trying to find the length of this side here, CD. So let's label our sides. So if this is the right angle, the side opposite it is called the hypotenuse. That's the hypotenuse. 28 degrees is the size of the angle, and the side opposite it, the CD, is equal to the opposite, so that's the opposite, and then that means that the BD is going to be the adjacent, so that means that BD is the adjacent. So if we have a look at that triangle, we've got the BC is the hypotenuse, it's opposite the right angle, we've got the CD is the opposite, it's opposite the 28 degrees we've been given in the question, or that we've worked out, and BD, this side here, the 5.13 and so on centimeters, is the adjacent. And let's jot down our triangles. Two old angels skipped over heaven, carrying a harp. So let's have a look and see which sides we're using in this question. So we're trying to find the opposite, so we're going to be using O. We've got the adjacent, and we don't actually need, and we're not trying to find the hypotenuse. So let's cross off the H and cross off the triangles that involve the hypotenuse. So we're going to be using tan, and we want to find the opposite, so we're going to cover up O, and the opposite will be equal to the tan of the angle multiplied by the adjacent. So the opposite is equal to the tan of the angle multiplied by the adjacent. Now let's substitute our values. The opposite, so that's going to be CD, or I've labelled it X, so I'm just going to call it X for the moment, is equal to tan of theta, so the tan of the angle, so tan, and then open up our brackets, 28, close brackets, and then multiply by the adjacent, and that's our 5.13 and so on. And I've still got that on my calculator display. Just going to scroll down a little bit. So X is equal to, and I'm going to press the tan of 28, close brackets, multiplied by answer. And whenever I do that, I get that's equal to 2.72783 and so on centimeters. And since we're done, we can round that. Let's round the two decimal places. That'll be 2.73 centimeters. So the length of CD is 2.73 centimeters, and that's it. Okay, let's have a look at our next question, question number 19. So question number 19 says that ABCD is a rectangle. So here's a rectangle, and we're told that BD, so the length of the diagonal, is equal to 9 centimeters, and we're told the angle BDC, so BDC, this angle is 40 degrees. And part A says work out the length of BC, so we want to work out the length of BC, this side here. So let's start off by focusing on this right angle triangle here. So the right angle triangle BCD. So that's a right angle there, because obviously it's a rectangle, so that's a right angle. We've got the angle here is 40 degrees, so that means the side opposite it would be the opposite. If this is the right angle, that means that 9 is the hypotenuse, that's the hypotenuse. And then we've got this angle here, and actually then the bottom side here will have to be the adjacent. So we've got the opposite, the hypotenuse, and the adjacent. And we've been asked to work out the length of BC, so let's jot down our triangles. Two old angels skipped over heaven, carrying a harp. Now in this question we're trying to work out the length of BC, so we want to find the opposite. We've been given the hypotenuse, so we're not using the adjacent, so we can cross that off, and that means we're not using that triangle and we're not using that triangle. So in this question we're going to be using sine, and we want to work out the length of BC, so that's the opposite. So if we look at our triangle, we're going to cover up the O, and we're going to do the sine of the angle multiplied by the hypotenuse. So let's write that down. The opposite is equal to the sine of the angle, so sine theta, multiplied by the hypotenuse. And let's substitute in our values. The opposite, which in this question is BC, what we're trying to find, is equal to the sine of the angle, so that's going to be the sine of 40, so the sine of 40 multiplied by the hypotenuse. And in this question, the hypotenuse is 9, so multiplied by 9. So if we do the sine of 40 multiplied by 9, that'll give us our answer. That'll be the length of BC. So BC is equal to the sine of 40, close brackets, multiplied by 9, and that's equal to 5.785 and so on centimeters. So that's the length of BC. So BC is equal to 5.785 centimeters to 3 decimal places. Okay, let's have a look at the next part, part B. Part B says work out the perimeter of the rectangle. So if we go back up, we want to find the perimeter of this rectangle. So that means, let's actually change color of ink here. We know the length of the width, so we know the length of BC is equal to 5.785 and so on centimeters, and still on my calculator display because I may need to use that. And if that side's equal to 5.785 and so on, this side's equal to 5.785 and so on centimeters. Now, if we want to find the perimeter, we're going to need to know the length of the rectangle. So we want to find the length of either AB or CD. So we want to find the length of the rectangle. Now, we could use trigonometry for that, or we could use Pythagoras. Either one would be fine. So I'm going to use Pythagoras, and I'm going to use this right angle triangle on the top here. It's a right angle triangle, because remember, it's a rectangle. And obviously, our hypotenuse, the longest side, is the side opposite the right angle. So that's going to be our C. Remember, whenever we're doing Pythagoras, which is A squared plus B squared equals C squared, we label the sides A and B being the two shorter sides and C being the longer side, the hypotenuse. So here the 9 centimeters will be the hypotenuse. Let's let our A be equal to 5.785 and so on. And then let's let this side here be equal to B. So that means we'll have, if we substitute those into Pythagoras' theorem, let's do that down here. So A squared plus B squared equals C squared. A squared, so that's going to be 5.785 and so on. And I'm going to use my calculator to display that. I'm not going to actually round it. Squared plus B squared, which we're trying to find, B squared is equal to C, which is the hypotenuse, which is 9 squared. So let's square this. So as I said, it's on my calculator display already, so I'm just going to do answer squared. And that's equal to 33.4672 and so on. Plus B squared is equal to 9 squared is equal to 81. So we've got the 33.4672 and so on, plus B squared is equal to 81. So if I take this away from both sides, so if I subtract 33.46 and so on from the left hand side and the right hand side, that will leave us with just B squared on the left hand side, and that's equal to, I'm going to press 81, subtract answer, and that's equal to 47.5327 and so on. So that's B squared. If we go back up, that's B squared. We want to find just B because obviously we want to find the perimeter of this rectangle. So we're now going to square root to find B. So let's go back down. We want to square root this. So B will be equal to the square root of 47.5327 and so on. And when we square root that, so the square root of answer, we get that's equal to that B is equal to 6.8943 and so on centimeters. So let's go back up to our rectangle. So that means that we found B to be 6.894 and so on centimeters. And that means that the length down here would be 6.894 and so on centimeters. And we want to find the perimeter of the rectangle. So we just need to add up our lengths. So let's do that. As you can see here, I've shown my method that I'm adding up the two widths and the two lengths. And whenever I add those up, I get that's equal to 25.3589 and so on centimeters. And let's round our answer to 2 decimal places. That'll be 25.36 centimeters, and that's it. Okay, let's have a look at question number 20. So question number 20 says, shown below is a parallelogram, and as you can see, it's a parallelogram or a pushed over rectangle. And we've been asked to calculate the area of the parallelogram. So the base of the parallelogram is 10 centimeters, and the length of this side is 7 centimeters, and the angle, this acute angle, is 50 degrees. Now we want to find the area of the parallelogram. Now to find the area of the parallelogram, we do the base multiplied by the perpendicular height. So if I'm just actually going to mark on the perpendicular height. If we can find this height here, the distance between the two parallel sides, then what we can do is we can multiply this height by 10, and that'll be the area of the parallelogram. Now you may notice here that's a right angle triangle. And let's label our sides. If that's the right angle, that means the 7 is the hypotenuse. And because this is our 50-degree angle, that means that this side would be the opposite. And then that means that this length here would be the adjacent. Now in terms of our triangle, our right angle triangle, we're using the hypotenuse, we're trying to find the opposite, and we're not using or trying to find the adjacent, so let's cross that off. Now in terms of our triangles, 2 old angels skipped over heaven carrying a harp. Now we're not using the adjacent, so let's cross off the triangles with an A in it, so that means that we're going to be using the sine. Now we want to find the opposite, so let's cover up O. That means the opposite is equal to the sine of the angle multiplied by the hypotenuse. So let's write that down. The opposite is equal to the sine of the angle multiplied by the hypotenuse. Now the opposite in this question, well, that's just the opposite. So the opposite is equal to the sine of the angle, so that's the sine of 50, so the sine of 50 multiplied by the hypotenuse, and the hypotenuse of this triangle is equal to 7 centimeters, so multiply by 7. So the sine of 50 multiplied by 7, making sure I close my brackets on my calculator, is equal to 5.3623 and so on centimeters. So that means the height of this parallelogram, the perpendicular height, is 5.3623 and so on centimeters. So to find the area of the parallelogram, so the area is equal to the base multiplied by the perpendicular height, so we're just going to do 10, the base multiplied by the perpendicular height, which is 5.3623, 0.3623 and so on, and that's equal to 53.623 and so on centimetres squared. And that's it. And let's round our answer to 2 decimal places, so the answer would be 53.62 centimetres squared, and that's the area of the parallelogram. Okay, let's have a look at question number 21. So question number 21 says a regular hexagon can be divided into 6 equilateral triangles. And the diagram below shows one of the equilateral triangles. So we've got an equilateral triangle here, and it's got a side length of 5 centimetres. That actually means that the regular hexagon has got a side length of 5 centimetres, and so does this equilateral triangle. And the angle is 60 degrees, and that makes sense for an equilateral triangle. And we've got this distance here, the height of the triangle x. Okay, and part A says use trigonometry to find the height x of the equilateral triangle. So we want to find this height x of the equilateral triangle. And if we have a look here, there's a right angle triangle. So here's a right angle triangle, and we've got a right angle, we've got a 60-degree angle, and we've got x. Now the whole base was 5 centimeters, so that means that half of it will be 2.5 centimeters. So this side is 2.5 centimeters. We've got the height x, and this is the angle. So let's label our sides. So this would be the hypotenuse opposite the right angle. Because this is our 60-degree angle, that means that x is the opposite, and that means that this side here would be the adjacent. In this question, we're trying to find the opposite. We've been given the adjacent. We're not using the hypotenuse. We're trying to find the hypotenuse so we can cross that off. So 2 old angels skipped over heaven carrying a harp. So we're not using any of the triangles, any of the ratios that involve the hypotenuse. So let's cross those off. So in this question, we're going to be using tan. Now we want to find the opposite, so we cover up the opposite. That means the opposite is equal to the tan of the angle multiplied by the adjacent. So let's write that down. The opposite is equal to the tan of the angle multiplied by the adjacent. So the opposite, and in this question the opposite is equal to x, so x is equal to the tan of the angle, so that's the tan of 60 degrees, multiplied by the adjacent, and the adjacent is 2.5 centimeters, 2.5. So if we do the tan of 65, making sure we close brackets, multiplied by 2.5, that'll be the height of the triangle. So the tan of 60 degrees multiplied by 2.5 equals 4.330127 and so on centimeters. So that's the height of the triangle, the height of the equilateral triangle. Okay, part B. Part B says calculate the area of the equilateral triangle. So we want to find the area of this triangle. Now to find the area of a triangle, we just do half the base times the height. So we just need to do, let's write that down, the area is equal to half the base multiplied by the height. So the half the base, so the base is 5, so we're going to do half of 5, and we're going to multiply that by the height of the triangle, which was 4.3301 and so on centimeters. Now that's on my calculator display, so I'm not going to round it. So I'm now just going to type in 0.5 multiplied by 5 multiplied by answer, and that's equal to 10.825 and so on centimeters squared. So that's equal to, I'll just write our answers in, 4.33 to 2 decimal places, and that's equal to 10.825 centimeters squared to 3 decimal places. And part C says calculate the area of the hexagon. Now we know the area of one of the triangles, and the question said that the regular hexagon is made up of 6 equilateral triangles. So if we just, because we know the area of this triangle, if we multiply it by 6, we get the area of the whole thing. So let's do that. So let's multiply the area of one of the triangles, so 10.825 and so on, and multiply that by 6. And that's equal to 64.9519 and so on centimeters squared. So that would be 64.952 centimeters squared to 3 decimal places, and that's it. Okay, let's have a look at question number 22. So question number 22 says, shown below is an isosceles triangle ABC, where AB is equal to BC. So AB is equal to BC. So those two sides have got the same length, which is 30 centimeters. So that's 30 centimeters as well. And part A says work out the size of angle BAC. So we want to find the angle BAC. So the size of this angle here. Let's label X. So we want to find the size of that angle there. So let's actually divide our triangle into 2 right angle triangles. So let's cut it down in the middle. So that would be a right angle. And because it's an isosceles triangle, if you cut it in half, that would mean that this distance here would be 7 centimeters, half of the whole distance. And we've got the length of the hypotenuse, which is 30 centimeters. So let's label our sides. So we've got our right angle. So that means that this would be the hypotenuse. The side here, the one opposite the angle X, this height of the triangle would be equal to the opposite. And that means that the side left, this side here, the 7 centimeters would be the adjacent. Now if we just write down our triangles, 2 old angels skipped over heaven carrying a harp. we're trying to find the size of the angle. We've been given the adjacent and the hypotenuse, so let's cross off the opposite and cross off the triangles that involve the opposite. So we're going to be using the cos, and we want to find the angle. Remember, if we want to find the angle, we will cover up the tan, the sine, or the cos. So in this case, we're going to cover up the cos, and that's equal to the adjacent divided by hypotenuse. So the cos of the angle, so the cos x is equal to the adjacent divided by the hypotenuse. So that means cos x, so the cos of the angle, is equal to the adjacent, which is 7, divided by the hypotenuse, which is 30. So we've got that the cos of this angle is 7/30. So this angle obviously isn't 7/30. So we want to get rid of the cos. So we're going to do the inverse cos to both sides. And that would be the x is equal to the inverse cos, so cos minus 1. And then instead of doing 7 divided by 30, I'm just going to, on my calculator, type in 7/30 and then close brackets. And when I do that, I get that x is equal to 76.5066 and so on degrees. And let's just round our answer to 3 decimal places. So that'll be 76.507 degrees to 3 decimal places. Okay, let's have a look at part B. Part B says calculate the size of angle ABC. So we want to find the size of angle ABC. So if we go back to our whole isosceles triangle, we want to find the size of the angle at the top. Now we know the size of this angle. This angle here is equal to, actually I'm just going to change colour of ink to green. So we know the size of this angle here. The size of this angle is 76.506 and so on. And this angle here would be the same. That's 76.506 and so on. And with the angle at the top, ABC. So if we look at the whole isosceles triangle, we know 2 of the angles. So if we just add those up and take it away from 180, we can find the size of the angle at the top. So let's do that. So let's do 76.506 and so on plus 76.506 and so on, and see what we get. And now that's on my calculator display already, so I just need to do answer plus answer, or answer times 2, and that's equal to 153.013 and so on degrees. Now we want to take that away from 180 degrees, so we'll just do 180 subtract 153.013 and so on, and that's equal to 180 degrees subtract answer, and that's equal to 26.9867 and so on. And if we just round that to 2 decimal places, that'll be 26.99 degrees, and that's it. Okay, let's have a look at question number 23. So question number 23, you can see we've got Humphrey and he's flying a kite, and the length of the rope to the string to the kite is 8 meters. The angle between the rope or the string and the horizontal is 63 degrees, and he's holding the string 80 centimeters above the ground. And we're told, with that information, the handle's held 80 centimeters above the ground, the string is 8 meters long, and the string makes an angle of 63 degrees with the horizontal. And we've been asked to calculate the height of the bottom of the kite above the ground. So we want to find the height, this distance here from the kite all the way to the ground, the height of the kite above the ground. Now if we start off by looking at this right angle triangle, so here we've got a right angle triangle here, we'll just ignore this 80 centimeters to begin with, and if we look at this right angle triangle, it's got a hypotenuse of 8 meters. This is 63 degrees, that means the side opposite that 63 degrees is the opposite, and then this distance here, this length would be the adjacent. So we've labelled our sides of the triangle, and let's write down our triangles. 2 old angels skipped over heaven carrying a harp. So we want to find this distance here, we want to find the opposite. We've been given the hypotenuse, so in this question we're not going to be using, or if I'm trying to find the adjacent, so let's cross off any triangles with a in it. So we're going to be using sine. So we want to find the opposite, so let's cover up the opposite. The opposite is equal to the sine of the angle multiplied by the hypotenuse. So the sine of theta multiplied by the hypotenuse. Now the opposite, let's just call that x in this case, is equal to the sine of the angle. So that's the sine of 63 degrees. So the sine of 63 degrees. And we're going to multiply that by the hypotenuse, which is 8. So if we do the sine of 63 multiplied by 8, that will give us the distance from here all the way down to here. So that'll be that distance there. So let's do that and see what we get. And that's equal to 7.128 and so on meters. So that's the distance from the kite to here. Now we want to find the whole distance from the kite above the ground. Now Humphrey was holding the string 80 centimeters above the ground, or 0.8 meters above the ground. That's 0.8 meters. So if we add that distance, which is 7.128 and so on meters, and our 0.8 meters, this distance here, that'll be the height of the kite above the ground. So let's do that. So it's going to be 7.128 and so on plus 0.8, and that's equal to 7.928 and so on meters. And let's just give our answer to 2 decimal places. That'll be 7.93 meters, and that's it. Okay, let's have a look at question number 24. So question number 24 says a helicopter leaves Bristol and flies due east for 10 miles. So here we've got Bristol, and so that's Bristol, and the helicopter flies due east for 10 miles. So it flies due east for 10 miles. So it gets to here, and that's 10 miles. So that's Bristol. And then the helicopter flies 8 miles north before landing. So then it goes 8 miles north. So just say to here, and then it lands, that's 8 miles north. And we've been asked to work out the direct distance from the helicopter from Bristol. So you want to work out that direct distance there. So from Bristol to the helicopter, that direct distance. That's a right angle triangle because it went east and then north, so that's a right angle. And actually, we can just use Pythagoras here. If we use Pythagoras, we can work out the length of the hypotenuse of the triangle. So let's label our sides. So let's label them. So the longest side of a triangle, whenever we're dealing with Pythagoras, so we'll call that C, because remember a squared plus b squared equals c squared. The two shorter sides squared added up is equal to the longest side, the hypotenuse squared. So we've got c is the longest side, what we're trying to find, and then we've got our two shorter sides, a and b. So let's substitute those in. So we've got a squared, so that's 8 squared, plus b squared, that's 10 squared, is equal to c squared. 8 squared is 64, plus 10 squared, that's 100, is equal to c squared. So if we add those up, we get 164 is equal to c squared. And let's just turn that around. 164 is equal to c squared, or c squared is equal to 164. Now we just need to square root 164, because that's obviously not 164 miles. We need to square root it to find c. And the square root of 164 is equal to 12.806 and so on miles. So 12.806 to 3 decimal places. Okay, now let's have a look at part B. Okay, and part B says calculate the bearing of the helicopter from Bristol. So I've just drawn the sketch again where we've got Bristol and the helicopter flew 10 miles east and then 8 miles north, and that's where the helicopter is. I want to find the bearing of the helicopter from Bristol. So we draw a north line at Bristol because it's from Bristol, so that's our north line. And remember, the bearings are measured clockwise from north. So if we just go clockwise from the north line to the line that joins Bristol and the helicopter, that line, then if we find the size of that angle, that'll help us find our bearing. So we need to find the size of this angle here. Now what I'm actually going to do in this question is I'm actually going to find the size of this angle here, x. I'm going to find this angle because this is a right angle from the north line to east. So this is a right angle. So if I can find what x is, the size of this angle here, then what I can do is I can take that away from 90, and then that'll give us that angle, and then we can use that to find the bearing. So let's look at this triangle and let's find the size of this angle x. So if this is the right angle, this is the hypotenuse. If that's the angle, that's going to be the opposite, and then that means that this side, the 10 miles, is going to be the adjacent. Now in this question, we're using the opposite and the adjacent, so we're not using the hypotenuse. So we're going to do 2 old angels skipped over heaven carrying a harp, and we're not using the hypotenuse, so let's cross off any triangles that involve h. So we're going to be using 2 old angels. So we're going to be using tan. Now we want to find the size of the angle, so we cover up the t for tan, so that's the tan of the angle. So if we cover that up, we get the tan of the angle. Tan x is equal to the opposite divided by the adjacent. Now we just need to substitute in our values. The tan of x is equal to the opposite, which is 8, divided by the adjacent, which is 10. So that's 0.8 or 8 tenths. So we want to find out what x is, so we need to do the inverse tan. So x is equal to the inverse tan minus 1 of 8 tenths. And if we just type that into our calculator, we get the inverse tan of 8 tenths is equal to, that's equal to 38.6598 and so on degrees. So that's the size of this angle. Now we wanted the size of this angle here. So we're going to need to take 38.65 and so on away from 90, and that gives the size of this angle. So 90 subtract 38.6598 and so on is equal to, so 90 subtract answer, that's equal to 51.34 and so on degrees. So that means that this angle is 51.34 degrees. So I'm actually just going to write that in, 51.34 degrees. So that means that this angle is 51.34. Now remember, bearings have to have 3 digits. So I'm going to write it as 051.34. So that means the bearing of the helicopter from Bristol will be 051.34 degrees. And that's it. Okay, let's have a look at our next question. Okay, let's have a look at question number 25. So question number 25 says a boat is approaching a cliff with a lighthouse on top. So we've got a cliff which is 100 meters tall, and we've got a lighthouse which is 30 meters tall, and we've got the boat which is approaching them. And then we're told the angle of elevation from the boat to the top of the lighthouse is 20 degrees. So in other words, the angle between the horizontal and the line that is directly between the boat and the top of the lighthouse is 20 degrees. And then part A says, calculate the distance of the boat from the base of the cliff. So we want to find this distance here. So if we look at this right angle triangle, so we've got got a right angle triangle. We want to find this distance here, the distance from the boat to the base of the cliff. So let's call that x. And we know that this height, the total height from the sea up to the top, would be 130 meters. And we want to find this distance, and we've got this angle is 20 degrees. So that's fantastic. So let's jot down our triangles. Two old angels skipped over heaven carrying a harp. Let's label our sides. We've got the right angle triangle, so that means that this side would be the hypotenuse. The opposite would be the 130 meters because it's the opposite the 20-degree angle, and that means that this distance here, this side here, would be the adjacent. Now in this question, we're trying to find the adjacent. We know the opposite, and we're trying to find the hypotenuse. So let's cross that off and cross off any triangle using the h for the hypotenuse. So that means we're going to be using tan in this question. Now we want to find the adjacent. This distance is the adjacent. So if we cover up the the adjacent, we know that the adjacent is equal to the opposite divided by the tan of the angle. So let's write that down. The adjacent is equal to the opposite divided by the tan of the angle, so tan beta. So let's substitute in our values. So the adjacent, I've called that x, is equal to the opposite, 130, divided by the tan of the angle, so that's tan of 20. So if we do 130 divided by the tan of 20, that'll give us that distance. So let's do that. So x is equal to 357.172 and so on meters. So that's that distance, 357.172 meters. So let's write that down. 357.172 meters to 3 decimal places. Okay, part B. So part B says work out the angle of elevation from the boat to the top of the cliff. So if we go back up, well, we know the angle of elevation from the boat to the top of the lighthouse, but we want to find the angle of elevation from the boat to the top of the cliff. So let's draw a line joining those up. So let's draw a line from the boat to the top of the cliff. So we want to find that angle of elevation. Now what's fantastic here is we know this distance here. We know the distance from the boat to the base of the cliff. That's 357.172 and so on meters. And we want to find the size of this angle. And we also know the height of the cliff. The cliff is 100 meters tall. So if we look at this right angle triangle here, so this right angle triangle now, this one here, we've got there's the right angle. We've got the height of the cliff is 100 meters. We've got the distance from the boat to the bottom of the cliff being 357.172 and so on meters. So we can then hopefully find the size of this angle. Okay, so I've just drawn another sketch where we've got our boat. We've got the distance from the boat to the base of the cliff being 357.172 and so on meters. And I'm using that full value, so I'm not actually going to round that. And I've still got it on my calculator display. And the height of the cliff was 100 meters, and we want to find the size of that angle. So let's label our sides. So if that's the right angle, that's the hypotenuse. Opposite the angle would be the opposite, and that means that this side here will be the adjacent. Now in this question, we've not been given, or we're not trying to find the hypotenuse, so let's cross that off, and let's write down two old angels skipped over heaven carrying a harp. Now we're not using the hypotenuse, so let's cross off the triangles with h in it. So in this question, we're going to be using the tan, and we're trying to find the size of the angle, so we cover up the t, and then we do the tan of the angle is equal to the opposite divided by adjacent. So let's write that down. The tan of the angle, tan beta, is equal to the opposite divided by the adjacent. And then if we substitute in our values, the tan of our angle, tan beta, is equal to the opposite, which is 100, divided by the adjacent, which is 357.172 and so on. And that's on my calculator display. Now I don't want the tan of this angle, I want to find the size of the angle, so I need to do the inverse tan. And that'll give us that beta is equal to tan, the inverse tan of 100 over, and I open up brackets, 100 over 357.172 and so on. So my calculator, I'll just press shift tan and then press the fraction button, type in 100 on the numerator, and then on the denominator I'm just going to press answer because I've already got that on my, that's my previous answer, and then close brackets. And when I do that, I get that's equal to 15.641 and so on degrees. And let's just round that to 2 decimal places. So the angle of elevation from the boat to the top of the cliff would be 15.64 degrees to 2 decimal places. And that's it. Okay, let's have a look at our next question. Okay, let's have a look at question number 26. So question number 26 is our last question, and we're told that ABCD is a trapezium. So this is a trapezium. So that means that the AB must be parallel to CD, so the top's parallel to the bottom. And we're told that angle BAD is equal to 74 degrees. So BAD, the angle is 74 degrees. We're told that CD, so CD is equal to 19.2 centimeters. and we're told that AB, so the distance from A to B, is equal to 26 centimetres. And that's not been labelled on the diagram, but the distance from here to here is 26 centimetres. And if we go down, we're told that AM is 2.5 centimetres. So I'm actually going to put some of these measurements on the diagram. We're told that AM is 2.5 centimetres, so 2.5 centimetres. Now in terms of AB, we're told the whole distance from A to B is 26 centimetres. Now if AM is 2.5 centimetres, if we do 26 take away 2.5, that's equal to 23.5 centimetres. So that means that this distance is 23.5 centimetres from B to M. So we've got those measurements on the diagram, and the question says work out the size of angle ABC. So we want to find the size of this angle ABC, and it's been marked with an X force. So we want to find the size of that angle. Okay, so we want to find the size of this angle. Now, the first thing that I notice is that if we actually go from C up to the line AB, we would have a right angle triangle. So here's a right angle triangle, and we want to find the size of this angle X. Now, if we were able to find some of these sides, we've got 3 sides here. If we were able to find 2 of them, we'll be able to use trigonometry to find the size of this angle X. Now, what I notice here is that the distance from C to the line, this distance here, is the same as dm. So this length here, dm. So if I was to work out the size of dm, and I can by using trigonometry in this triangle, I can then put the same measurement here. So let's do that. Let's start off with this right angle triangle on the left hand side. And I'm just going to change color of ink. So looking at this triangle here on the left hand side, there's our right angle there. So that means that this length, AD, must be the hypotenuse. Because this is 74 degrees, this side must be the opposite, is opposite 74 degrees, and then this length here, this AM, must be the adjacent. So we want to find the opposite, and we've been given the adjacent, so we're not using or trying to find the hypotenuse. So let's jot down our triangles. 2 old angels skipped over heaven carrying a harp. So we're not using the hypotenuse, so let's cross off the triangles that involve H. So that means we're going to be using the tan. So whenever we're trying to find this opposite, we're going to be using tan. So let's cover up O, and the opposite is equal to the tan of the angle multiplied by the adjacent. So the opposite is equal to the tan of the angle, so tan theta, multiplied by the adjacent. Now the opposite is equal to dm, that's what we're trying to find. Dm is equal to the tan of the angle, so the tan of 74, and that'll be in brackets, multiplied by the adjacent, which is 2.5. And whenever we do that, we'll find the length of dm, and that's equal to 8.71853 and so on centimeters. So that's this distance here from D to M. So that means that the length from C up to the line must be the same. So that is equal to 8.71853 and so on. So that's that distance there. So we want to find another side of this right angle triangle. So if we were able to work out either that distance or that distance, we'll be able to use trigonometry to find the size of that angle. Now actually, if we have a look here, from C to D is 19.2 centimeters. So that means that from M to this point here would be equal to 19.2 centimeters from here to here. So that distance would obviously be the same as that distance. Now from A to M was 2.5. From M to this point here is 19.2, and we're told the whole distance is 26 centimeters. So if we take our 26 centimeters and we subtract 2.5 and we subtract the 19.2, we'll be able to find the distance from B to here. So let's do that. Is equal to 4.3. So 4.3. So that means the distance from here to here is 4.3 centimeters. And that's fantastic because we've now got a right angle triangle with 2 of the sides. So we can use trigonometry to work out the size of this angle. So I've just changed colour of ink again. I've changed to purple. And this is the angle we're trying to find. So let's label our sides on this right angle triangle. So if that's the angle we're trying to find, let's call that side the opposite. If that's the right angle, that's the hypotenuse. And that means that the 4.3 must be the adjacent. And let's jot down our triangles. Let's do it down here. Let's scroll down a little bit. We've got 2 old angels skipped over heaven carrying a harp. Now in this question, we've got the opposite and we've got the adjacent. We're not using the hypotenuse, so let's cross off the triangles involving the hypotenuse. So we're going to be using the tan. So because we're trying to find the size of the angle, we cover up the t, and that's cover up the tan, and that means the tan of the angle, so tan x is equal to the opposite divided by adjacent, so equal to the opposite divided by the adjacent. And that means if we substitute in our values, we know what the opposite is. The opposite's equal to 8.7 and so on. So the tan of x is equal to 8.718 and so on. And I've got that on my calculator display already. And then I'm going to divide that by the adjacent, which is 4.3, because remember the adjacent is 4.3. So divided by the adjacent. Now I'm not going to work this out. I could do 8.718 and so on, divide that by 4.3 if I wanted to, but I'm just going to leave it as a fraction. But what I'm going to do is I'm just going to get rid of our tan by doing the inverse tan. So we get x is equal to the inverse tan, or tan minus 1 off 8.718 and so on over 4.3. Close brackets. And let's just type that in our calculator. Is equal to, so x is equal to 63.747 and so on degrees. And let's just round that. Let's round the two decimal places. That'll be 63.75 degrees. And that's it. So these have been the video solutions to the trigonometry practice questions. In this video, I focused on using the formula triangles, those two old angels skipped over heaven carrying a harp. If you prefer using another approach, such as rearranging the formula, these are the other video solutions on Corbettmaths that show that approach. If you need any extra help on trigonometry, if you go to corbettmaths.com/contents and scroll down to video numbers 329, 330 and 331, there's 3 fantastic video tutorials there that can help you. Alternatively, you could scan this QR code. I really hope you found this video useful. If you have found it useful, could you please like it and please subscribe to the YouTube channel. Thank you. Cheers. Bye.